Can you imagine having a battery capable of giving you light, charging your laptop, powering tools, and even if you're in Spain, saving you from a blackout? Well, I'm going to introduce you to the Fossibot 2400, a charging station that can work independently or function as an uninterruptible power supply system. For those situations where we don't have electricity or we simply want to be protected against a power outage. This battery, as you see it here, has enough power to supply a house for at least half a day without any kind of restriction. So in this video, I'm going to show you how it works, what uses we can give it, and most importantly, whether it's worth it compared to other alternatives we find on the market. Let's start with the design of this Fossibot 2400. It's mostly built out of plastic. It weighs 22 kilograms and it has dimensions of 40 centimeters wide, about 30 or so in height and about 15 to 20 in depth. It's a battery that's mainly made to take with you to campsites, to have in motorhomes, or to keep at home as a power supply system in case of a power outage. To transport it, the options we have are to grab it by the handles on the top, and that way we can carry it with us like a suitcase. But I'm telling you, it's not an accessory that's comfortable to carry around all the time. It's really made to be kept in a fixed place. Because, as I said, it's quite heavy and pretty big, so it's not easy to move around. When we unbox this battery, we find that there's absolutely nothing else in the box. However, that's because there are 3 cables that will be used for charging, and they're stored in a top compartment of the battery itself, so that we always have them with us. The first one is a cable for home charging up to 1100 watts, up to 1100 watts. The battery will take 2 hours to fully charge. However, it has adjustable power at 900, 700, 500 or 300 watts, taking up to 7 hours if we want to do a slower charge. On the other hand, it's also possible to charge this battery using a car or camper connector, so that while we're on the move, we can charge this battery and then use it when we're stationary. And finally, we get a perfect adapter to connect it to solar panels if we've purchased the solar panel kit. Even if we don't buy it now, we'll still get the cable in case we purchase it later. I don't have it at the moment. It's a connector that we can use to connect solar panels in parallel and even in series. If not, they reach up to 50 volts, which is the maximum input voltage that this battery allows us for charging. Let's take a closer look at what this battery offers us in terms of input, output, and other connections. Let's start with the front. So follow me and we'll show you everything little by little. With the power button, we turn on this screen, which is very basic, where we can see the input power we're getting at this moment, which is 0, the current percentage, and the time it would take both to charge and to discharge the battery at the current rate. It shows infinity since nothing is connected. And here we have the output, which right now we're not using any power. What is this dial here for? Well, this dial is basically used to limit. When we connect the battery to a socket in our house, it controls the amount of power we want it to use. Did I tell you before that we can connect it at 1100 watts and it would take about 2 hours to fully charge, or we can lower it to 300 watts and it would take 7 hours to fully charge the battery? But we would give the battery a longer lifespan because we're charging it more slowly. We ensure that circuit breakers won't trip when we're at a campsite without much power and simultaneously using various devices. Can we regulate the energy consumption with this dial? Now let's start on this left side. Here we have direct current connections. This first one is a cigarette lighter connection, similar to what we would have in a car to connect any type of device. We have a connector that's compatible with certain electric motors. I've never encountered it before. These connectors down here are called Direct Current 5521 and are used for connecting household devices such as routers, LED lights, and for example drills, portable drill batteries, and so on. Honestly, I also don't have a way to show you how they're used. We turn on these 4 connectors using this little button here, and basically we can see in this part here that we have the continuous connection activated. The moment we deactivate it, everything we connect here will no longer have electricity. And let's move on to this little light here, which has 3 positions. One position turns it on to use as a flashlight, another position makes it blink, and another position will send and save our source signal, which would be in this case the second one. On the right side, we find different types of USB-C ports. First, we have 2 USB-A ports with Quick Charge 3.0 where we can connect all kinds of devices that support this standard. Then on the second row, we have two USB-C ports with power delivery up to 20W and then two more ports at the bottom. The first one has 100W, suitable for a computer compatible with power delivery. The same applies to this one, also with 20 watts. The USB ports are activated using this small button here. On the right side, the first thing we have is this little cover, which we always need to open whenever we're going to use the battery. The heat outlet is on this side and the inlet is on the left side. There will be two intake fans and two exhaust fans on this side. What are they going to do? Well, they're going to dissipate all the heat generated by the battery inside. The brand puts yellow warnings for us, indicating that it's important to open it and not leave it closed. Then at the bottom, with this button, we would activate the three household outlets that they're going to provide us with, between 220 and 240 volts, with a total power among the three of 2,400 watts of continuous power. On the left side, it's the same. We have this little cover that we need to open to allow the airflow to enter the battery. This button pops out during battery overload as a safety feature. It's currently deactivated but can be reset by pressing it. And then in this lower part, we have the input for both the household power, so we can charge the battery with a regular outlet and the input for the car charger or solar panel. This way, as I mentioned before, we can connect individually to the household power, solar panels, or the car charger. Or we can combine them to achieve a higher power of up to 1,600 watts of charging. We've prepared a small demo here of things we could connect to this battery. If we're, for example, at a campsite, we've lost power, or we're, for example, in a camper. With this, for example, heater. Okay, first of all, electronic devices consume very little power. Let's take a closer look at their consumption as we connect them. The first thing I have to do is turn it on. The USB charging is activated when I press the button. Now I'll connect it. First, the iPad is going to start charging. We see that it has 83%. And we see that, for example, the iPad with a consumption of about 16 watts, 15 watts could last about 50 hours, approximately 49. Well, that's about the range it's going to be. Keep in mind at all times that we have half the battery. That means this would be double if we had the battery fully charged, which would allow us to charge devices continuously for several days. Now we connect the laptop, which uses or should use a bit more power. Since we already have the USB ports activated, we have it connected to the 100W port, we start to see that we have a continuous consumption of about 70 watts, 75 watts. And with this, we could last about 28 hours, or well, about 25 or 28 hours. Now, when it stabilizes charging these devices continuously, which gives us more than a day. A charging laptop consumes more power now, but will use less once charged. However, listen, at the same time, we need to envision connecting a heater like this one. This heater consumes power at the lowest setting. 1,000 watts, which is enough to heat a room without any problem, and 2,000 watts if we set it to the maximum, which would even allow us to heat several rooms, a fairly large living room or whatever we need, or a poorly insulated room, which is enough to heat a room without any problem. At its maximum setting of 2,000 watts, it can heat multiple rooms, a large living room, or a poorly insulated space. All right, let's try what happens if we set it to the minimum and turn it on. Here we can see that it starts working without any problem. The consumption goes up to 1,100 watts, and we can see that with half the battery, we could power it for about an hour. So with a full battery, this heater would last us for 2 hours. However, if we use the maximum power, we will be reaching almost the maximum power that this battery can provide. We would only have half an hour or about an hour if we charged it completely. But I'm telling you, having this heater on for an hour uses up a lot because it gives off quite a lot of heat. Let's talk about the capacity and technology of this battery. This battery has a capacity of 2 kilowatt or 2000 volt, which is the same thing. And what is this going to be useful for? Well, just so you get an idea, for example, if we connect an iPhone, we can charge it up to 178 times. If we connect a television, we'll be able to use it for about 15 hours. Or, for example, if we connect a microwave, we'll be able to use it for 2.5 hours. I can give you some other interesting examples. Like, for example, we could connect a hairdryer for an hour. Or, for example, an electric saw for about 80 hours. Anyway, well, we can give a lot of examples, but just so you get an idea, my house, which is a 4-bedroom apartment, uses about 6 kilowatt hours in a day. So without holding back on anything at all, if we use this battery, it would last us for about half a day, more or less. However, if we're in a blackout and we realize we'll have to survive with this capacity for many hours, well, we might reduce the number of light bulbs we turn on and so on, and we could easily supply a house's energy for a day without any problem. In the end, a refrigerator hardly uses any energy, basic lights, charging phones, a laptop. Basically, these things use almost nothing and we'll be able to power them for a long time. It's important to point out that the technology of this battery is lithium iron phosphate, 4. I don't know much about batteries, but basically what Fossibot promises us in this case is that the cells that make up this battery will have a lifespan of more than 3,500 charge cycles, which would give us about 10 years of use if we do 1 charge cycle per day. But what it's telling us is that this battery will maintain 80% of its capacity even after a long period of use. The technology used in portable batteries is usually lithium. And well, these are technologies that degrade much more. Well, there's LiFePO4, which is a compound that degrades much less and lasts many more years. So in the end, how is this going to affect us? It means that the investment we make will last much longer, and if we think about it in terms of amortization, a battery of this type will end up being much cheaper for us. We talked earlier about the power output that each of the ports gives us independently. However, this battery's maximum power delivery capability is 2,400 watts. However, if at any point we connect, for example, the compressor of a refrigerator or an electric motor, which consume much more power at startup, this battery is capable of delivering up to 4,800 watts during peak moments, but then continuously 2,400. Also, I haven't had any kind of problem, for example, with the use of computers and microphones. If we don't have a perfect sine wave, is it possible that they might introduce noise? And that, well, for example, a microphone might introduce those characteristic noise sounds that you've surely heard at some point in your life. But anyway, like I said, this is a perfectly generated wave, so you won't have any noise problems with any of the devices you connect. As for charging options, we can charge this battery using a household outlet, which provides up to 1,100 watts of power to fully charge it in 2 hours. We can purchase a solar panel kit with power options of 200, 400 or 420 watts, even reaching up to 500 watts, which will allow us to charge the battery in 4 hours. This is possible because it has integrated maximum power point tracking technology, which is a technology that allows us to charge using solar panels. Then we'll be able to charge it in a car at 12 or 24 volts if we have, for example, a truck. And in this way, well, in the end, in a much slower way, but we'll be able to make up for the discharge during a long trip, which we can then have at a campsite during the night. Also, I should mention that we can combine several charging methods, such as home charging with solar panels to achieve up to 1,600 watts of power. Anyway, if we set this up at home as an energy storage system, you should know that we can charge it in those 2 ways. And one thing I was really looking forward to testing is seeing the power we get from a car lighter. For example, I connected it here to my car's lighter. We took this cable with the XT90 port, which we use to charge the battery, and we're going to plug it into this lower part here. As you can see, for now, it's not supplying any electricity, so we're going to try starting the car. And we see that a car lighter gives us about 100 watts, which isn't bad at all, because we're going to be able to charge half the battery in 11 hours. Let's see. Obviously, this isn't practical, but it's true that if at any moment, say we're on a road trip or something like that, well, we can charge a certain amount of electricity that we can then use, for example, during the night. Then, for those of you living in Spain, I'm sure that a few weeks ago you experienced, myself included, the widespread blackout we had, and this could have helped us in that situation. This battery can be used as an uninterruptible power supply system, which basically works like this. We connect the battery to a home outlet, and then all the appliances like a laptop, router, and even appliances like a refrigerator, we could connect it to the battery, and the battery would work as a bypass, meaning everything we connect directly plugs into the power grid. In the event it detects that the power grid goes out, what it would do is switch to using the battery cells it has inside in under 8 minutes. This way nothing would turn off during a power outage, not even the computer or router, and we wouldn't even notice. This use is quite important because it doesn't just limit the use of this battery to camping, a van or a camper, but it also makes a lot of sense to have it in a domestic setting. And finally, something I think is important and could be convenient to use is the mobile app, which I'm going to show you next so you can see what options it offers us. To view incoming and outgoing power and enable or disable ports. You can even set a lower limit for discharge and an upper limit for charging so you don't degrade the battery cells too much during their lifespan. The mobile app is simple, but what is its purpose? Well, it has Bluetooth so you can connect it, for example, in this case, since we have it nearby, but it also has Wi-Fi in case you want to control it remotely. In this case, we would see the same data. Right now, we're drawing power in both direct current and alternating current, specifically around 2100 watts. Imagine that, for example, here we have connected the iPad and the computer, and here the heater. If we turn off the heater, which we can do from this little button here, we can see that the consumption drops to about 57 watts. And well, we can also see the battery percentage. In the same way, we can activate, for example, the flashlight or the ports I mentioned at the beginning, which are useful, for example, for airplane batteries, for the car cigarette lighter connector, and so on. Lastly, something I find quite interesting is the energy management, where we can set the maximum level we want it to discharge, for example, to protect the battery, down to 20%, and the maximum we want it to charge to, which is currently set at 100%. But we could limit this to 20 and 80 if we want to further preserve the lifespan of the battery cells. In short, an extremely versatile battery. As I mentioned, it's not only practical when going out, on trips with a camper or to a campsite, but also very useful in domestic settings. Also, it's a battery that I think is worth every euro we invest in it because of that technology I was telling you about. Lithium iron phosphate. 4, which means we get up to 3,500 charge cycles before it degrades by 20%, making it very durable, much more than the competition. The price of this battery starts at 800 euros, and with solar panels, it could reach 1,000 or 1,200 euros. The price might seem high initially, but it's consistent with what we've seen for other batteries, depending on the pack we choose to purchase. That we've reviewed on the channel, which offered much less than this one, in terms of capacity, connections, and ultimately also that technology that gives us 3,500 charge cycles.